So we come now to our next topic, which is about limit. So before we define, or before I describe what is a limit, let us first describe the behavior of this function. So we have f of x equal to x squared minus 1 over x minus 1 for values x near x equal to 1. Okay, so first, if we describe the domain of this function, x should not be equal to 1, because if x is equal to 1, the denominator will become 0. So this function is not defined at x equal to 1. Sorry, at x equal to 1. But any number near 1 is still part of the function. So if we evaluate this function, or simplify this function, so we have x squared minus 1 over x minus 1. We could rewrite this as, take the factor of this, so that would be x plus 1 times x minus 1 divided by x minus 1. So we could cancel out this, and the result is just x plus 1. So therefore, this function is just a linear function, or a straight line, x plus 1. Okay? Okay? But x cannot be equal to 1. So anong ibig sabihin nito? Ako din yung sasagot. If we graph this, if we graph the first function, we have y equal to x squared minus 1 over x minus 1. You will find out that this is just a straight line. That is the same as y equal to x plus 1. That is the same line. But what would be the difference of these two? Okay, if we just look at this line, let's say na this line is not derived, or hindi siya galing dito sa previous line natin. So ito siya. So that means this graph is just continuous at any point. Pero remember na that is the same graph of this. Pero when we describe the domain, there is no value for x equal to 1. Meaning, ang x equal to 1, I hope I could show my cursor, pero parang wala. I can't show my cursor. Pero, at x equal to 1, wala siyang value dun. So, meaning, if we zoom this in infinitely, i-zoom natin to siya, meron siyang maliit na butas. No? It will not be, disconnected siya. So parang nakadikit lang siyang ganun, but it is not continuous. Apparently it's just a straight line. So eto lang siya. Pero actually at point x equal to 1 dito, let's say this is x equal to 1, at point dito, so let us zoom that in. Let's say eto. Let's say this is x equal to 1. So at this point, butas siya. No? It's not continuous. So meaning putol siya dyan banda. So putol siya dyan. Okay, pero sobrang liit ng disconnection that you cannot see it. Hindi mo siya makikita by just zooming that in. Ayaw nga ma-erase. Okay. So ito, that means na yung graph natin kanina is discontinuous. May siya, may gap siya dito. May gap siya right here, ayan. So the gap is too tiny na kailangan pa natin i-zoom in pa siya 1,000, 1 million times para makita yung gap, kasi it appears that they are connected because kung titingnan natin, ang restriction natin is just at x equal to 1. That means the function is still defined at x equal to 0.9999999, and it also defined at x equal to x equal to 1.000000001. These are values that is very close to 1 but is not equal to 1. Pero at x equal to 1, at x equal to 1, di siya pwede, di ba? Okay? So therefore we say, ayan, ito. Dyan. So, klaro na yung gap. So, therefore, we say that at this gap, x approaches 1. Kasi di siya pwede sa 1, pero it approaches 1. And as x approaches 1, this function f of x, which is equal to x squared minus 1 over x minus 1, which is eto siya, eto. This is now our f of x, diba? Because this is our f of x axis and this is our x axis. Okay? So as x approaches, or if the value of x approaches 1, so ito yung 1 dito, as x approaches 1, papalapit siya sa 1 or it creeps in 1, the function approaches this, which is equal to, ito siya, this is equal to 2. Diba? So, we have f of x equal to x plus 1 if we simplify this. So at x equal to 1, so f of x is equal to 2. That's 1 plus 1. So as x approaches 1, habang mapalapit siya sa 1, this function approaches 2. But x cannot be equal to 1 because the function is not defined for values or for x equal to 1. So therefore, f of x cannot be also equal to 2. But as x approaches 1, f of x approaches 2. So ano naintindihan? Ibig ko sabihin, right at this gap, etong gap mismo, the coordinate of that gap is 1, 2. But for this function, 1, 2 does not exist. Again, for this function, 1, 2 does not exist. Pero values close to 1 and close to 2 for f of x exist, diba? So that means eto siya, let's say etong point na sobrang lapit but not equal to 1, that would be 0.99999, and yung pares niya of course is 1.9999. Ganun. Okay? So, kung titingnan natin yung using our calculator, lagay muna natin yung x squared minus 1 over x minus 1. Over x minus 1. So, again, let us establish that at x equal to 1, yan, if x equal to 1, the result is indeterminate. So, it doesn't exist. But, how about if we try values that are close to 1? So, ano ba yung mga values close to 1? Let's say 0.9 is close to 1. So let us substitute x as 0.9. The result is 1.9. Okay, that's close to 2. So if x is, let's move that closer to 1. 0.99 is much closer. The result is 1.99. So mas lumapit pa sa 2 yung result. So if x is much closer, 999, the result is 1.999, which is more closer to 2. So if x is 0.9999999, that is very, very close to 1, the result is also very, very, very close to 2. So therefore, their conclusion, we could say that as x goes near or creeps to 1, the function goes near 2, diba? Palapit siya sa 2. So to give now the informal definition of a limit, this is, eto na yung ginawa natin kanina. If f of x is defined for all x near a, except possibly at a itself, and if we can ensure that f of x is as close as we want to L by taking x close enough to a, but not equal to a, we say that the function f approaches the limit L as x approaches a, and we write the limit of f of x as x approaches a is equal to L. So yun yung informal definition of a limit. So medyo magulo siya because masyadong maraming words near a except possibly at a itself. But through the previous example, I think this would make sense. Okay? So let's say if f of x, eto na yung x squared minus 1 over x minus 1, is defined for all x near a, di ba? meron siyang values near A. Yung A natin dito is yung 1 kanina. It is defined at all values near A, meaning meron siyang 0.99999, meron din siyang 1.000001, so that are values near A. So merong defined siya for values near A, pero di siya pwede at A itself. So like this, the value of x cannot be equal to 1. So dito rin, the value of x cannot be A itself. So if we can ensure that f of x is as close as we want to L by taking x as close enough to A. So yung ginawa natin kanina, yung value ng x, nilapit natin sa 1 kanina. So the value of f of x, palapit ng palapit sa 2. Okay? So, but not equal to A. So we say that the function f approaches the limit L as x approaches A. So yun yung nangyari kanina. The function f of x equal to x squared minus 1 over x minus 1 approaches the limit 2. Diba? Kasi kanina sa calculator, papalapit siya ng papalapit sa 2. Habang yung x papalapit ng papalapit sa 1 as x approaches 1. And we write this. Okay? So therefore, the limit of f of x as x approaches 1, para dito, I'm defining f of x na doon sa example kanina, the result is 2. So generally, we have this. Now, bakit tinawag na informal definition of a limit dito? Ako na yung sasagot. It is informal definition because this is too vague. When we say x near A, that is too vague. Iba-iba kasi. This is very relative. So, depende ano yung tinitingnan mo or how near is near or how far is far. Okay, so let's try to answer problem 3.1. We have 3 functions here to evaluate the limits of. So let's start with problem 3.1a. So for problem 3.1a, we have the limit of the function. So this is our f of x, or this is the function. We have x squared plus x minus 2 over x squared plus 5x plus 6 as x approaches negative 2. So, okay. Gawin natin, let us first evaluate, or let us first take a look at the function. Okay? So, our function here is x squared. I-factor out na lang natin. So, in factored form, that's x plus 2 times x minus 1. And the factor of the denominator is x plus 2 times x plus 3. Okay, so therefore, for this particular function, x, or the domain, or x, is not defined at x equal to negative 2. Diba? X cannot be equal to negative 2 kasi masi-0 to. So, hindi siya defined at that point. Also, x cannot be equal to negative 3. Because kung negative 3 to, masi-0 din to. So, ito yung mga restriction natin. So, if it is not defined, or if the function is not defined at these points, so what would be its limit, or what does the function approach at when x approaches negative 2? So, saan siya nag-approach when x approaches negative 2? Because it cannot be equal to negative 2. Okay, so yun yung sasagutin natin. So if you notice, ito, we could just cancel out x plus 2. So ito na mabilin sa function, matitira sa function. So therefore, we could rewrite this as limit of x minus 1 over x plus 3. And again, ito siya, galing siya dito. So meaning, right in this function, x cannot be equal to negative 2 pa rin. Okay? So over, as x approaches to negative 2. Okay? So in order to evaluate this, if we are evaluating limit, we know that we cannot substitute negative 2 to the function. Pero kung mag-evaluate na tayo ng limit, it is also similar to evaluating functions. Pero bear in mind that we are not actually substituting the exact value x equal to negative 2, but only values near that. Okay? Near that. So the answer is also near the result of the limit. Anong ibig sabihin? So, to evaluate this, so parang ganito. we let x be any number close to negative 2. So that would be x is any number close to negative 2 minus 1 over any number close to negative 2 plus 3. So the result is very close but not equal to, very close to negative 3 over positive 1, which is negative 3. So ibig sabihin, as x goes closer to negative 2, the limit of this function gets closer to negative 3. Yun yung ibig sabihin niya. Okay? So meaning kung may limit tayo, we are talking about values near that particular value na naka-state dito. So we are talking about values of x that is near negative 2 and values of and the result is a value that is near negative 3, or the limit of this is equal to negative 3. Saan natin diyan? So tingnan natin yung graph. So naka-graph na ko dito. I already graphed the function, and we know that x cannot be equal to negative 2 and negative 3. So these points are actually asymptotes of this function or this curve. Okay, ito siya. Mga asymptotes to siya because that would vertical asymptote. So the result is infinity, diba? So pag vertical asymptote, that means y is equal to infinity. I discussed that in the bridging lessons. Anyway, so tingnan natin yung x equal to negative 2. Etong line na green, the green line. So kung titingnan natin sa green line, apparently meron naman siyang intersection, 'di ba? It appears na meron siyang intersection, pero if we go to that point exactly, ayan, when x is negative 2, sana nakikita nyo, when x equal to exactly 2, ang pares is undefined. Ayan. Ang pares niya is undefined. But if x goes closer to negative 2, so tingnan nyo yung yung abscissa. As it goes close to negative 2, yung pares niya, yung ordinate, gets closer to negative 3. Okay? Pero pagdating niya sa negative 2 exactly, it's undefined. Diba? It's undefined. So, ito rin dito. As it goes closer to negative 2, the pares, the function, gets closer to negative 3. Okay? So, therefore, the limit of this function, meaning the limit of that curve, as its x value gets closer to negative 2, is negative 3. So, yun lang ibig sabihin niya. So, yun yung overall sense ng limits. Okay? Okay, now let us proceed to problem 3.1b. 3.1b. Ayan. So, don't cry yet. This is too easy. Or wag mo nang iiyak, madali lang to. Okay? So, we'll evaluate this limit by first simplifying this. So, simplify muna natin siya. The limit as x approaches to a. So, let us simplify the numerator. The LCD is ax or xa. So, let's just write xa. So, xa divided by x times 1, that would be a, minus this divided by this is x times 1, that would be x. Then, all over x minus a. Okay, ayusin muna natin. So, that would become a minus x over xa times x minus, kalimutan ko yung limit. So, ilagay natin pa. May limit pa. So, para, ayan. So, eto. Yan. So, that would be equivalent to, eto, if we take a look at this and this, parang similar lang sila. So, how about, let us factor out negative here. So, that would be negative. So, eto magiging positive na siya. So, unahin natin. Then, eto maging negative na siya. So, maging negative a. Diba? So, kung i-distribute natin to, that would become this. Exactly. So, over xa, then x minus a. So, from here, we could cancel out x minus a. So, therefore, this becomes, iba na yung 8. This would become the limit of negative 1 over xa as x approaches a. So that would become negative 1 over, so substitute na lang natin to dito. So that would be a times a, the result is negative 1 over a squared. So therefore, as habang yung x papalapit sa a, yung value ng etong value na to will go close to negative 1 over a squared. So ito yung answer natin. So madali lang pag-evaluate. Parang nag-substitute lang, pero always remember the theory behind limits. Kahit parang functions lang siya na nag-simplify and nag-substitute, but there's something deeper about that. So let's answer 3.1c, which is this: the limit of square root of x minus 2 over x squared minus 16 as x approaches to 4. Again, if we define the function, di siya pwede sa x equal to 4, di ba? For the function f of x equal to square root of x minus 2 over x squared minus 16, x cannot be equal to 4. Pero, meron siyang limit. Meaning, kung mag-approach siya sa 4, kasi di siya pwede sa 4, pero kung mag-approach siya sa 4, it will approach a certain value. Okay? So, yun ang ibig sabihin nun. So, we do that again, similar dun sa ginawa natin. That is simply factoring, no? So, the numerator is square root of x minus 2. So, the denominator is x squared minus 16 as x approaches to 4. So, what we're gonna do, yung gagawin natin is, let's factor out the denominator. That would be x minus 4 and x plus 4. This is special product, sum and difference. Okay? So, dito, eto siya, kung mag-substitute tayo dito, then di siya pwede kasi mag-0. So, it's not defined at that point, x equal to 4. But, eto siya, we could take this as square root of x. Remember that square root of x, or no, x is equal to square root of x squared. Okay? So, therefore, step by step lang muna. So, eto siya, we could imagine this as square root of x squared minus 4, which is a special product ulit. Diba? Square root of x squared is just equal to x. Actually, absolute value of x, which is x. So, this is equal to, i-factor out natin to, that would be square root of x minus 2 times square root of x plus 2 times, eto, don't need to factor that out anymore, x plus 4. We factored this out para ma-cancel out to. Okay, so if sige lang, for clarity, lagyan natin grouping symbol. So I could now factor this out. So therefore, we'll have this limit is equal to 1 over square root of x plus 2 times x plus 4. So therefore, the limit approaches, the limit is square root of 4 plus 2 times 4 plus 4. So the limit is equal to 1 over 32 pala. So the limit is 1 over 32. Okay, let's now proceed to the theorems on limits. So basically, we will just be dealing with how we evaluate limits or limits of functions. Okay, so first let us have these two functions. So let f of x and g of x, or it could be any other variables, hindi lang na x lang. F of x and g of x be functions, of course. Okay, so if we have so let's call this our first, for the first theorem on limit. So if we have limit of f of x plus g of x as x approaches to a, okay, that is equal to the limit of f of x as x approaches to a plus the limit of g of x as x approaches to a. Okay, so therefore the limit of the sum or difference of two functions. It could be also difference because it's just a additive inverse. The limit of the sum of two or more functions is just equal to the sum of the limits of the functions. Ayan. So that goes the same with difference. Now, for number 2, if we have limit of f of x multiplied by g of x as x approaches to a, that is simply the same as the limit of f of x as x approaches to a times the limit of g of x as x approaches to a. So therefore, we say that the limit of the product of two or more function is just equal to the product of the limits of each function. Okay? Pero, we know na related lang naman yung multiplication at division. But of course, we need to properly describe that. So for number 3, if we have limit of f of x over g of x as x approaches to a, that is equal to the limit of f of x as x approaches to a over the limit of, let me move that, g of x as x approaches to a, where the limit of g of x as x approaches to a should not be equal to 0. Of course, para di siya di siya undefined. Infinity, I mean. Okay, to cut this long discussion short, this is exactly what we did in the previous problem, di ba? So, observe na lang natin. Ito. So, that is exactly what we did. Kasi ito, when we evaluated ito, when we evaluated this, what we did was ganito lang. Kung long method pa siya, so ito, dugtungan lang natin ha. Kung long method pa yung ginamit natin, that would be the limit of x minus 1 as x approaches to negative 2 over the limit of x minus 3, plus 3 as x approaches to negative 2. And actually, the denominator is, the numerator and the denominator are still both sum and difference, diba? So, further, pwede din to limit of x as x approaches to negative 2 minus limit of 1 as x approaches to negative 2 over limit of x as x approaches to negative 2 plus limit of 3 as x approaches to negative 2. So basically, this is what we did here. So apparently, it looks like we just substituted, but actually, ito yung ginawa natin. Shortcut version na lang to siya. Okay? Ito yung ginawa natin. Of course, ito, common sense. What does x approach to when x approaches negative 2? Common sense, di ba? What would be, ano yung ina-approach ng x kung ang x mag-approach, or if x approaches negative 2? So, andyan yung answer. It will approach negative 2. So, that would be negative 2 minus. How about this? What would 1 approach to as x approaches negative 2? Of course, 1 is a constant. So, kahit ano pang i-approach ni x, di siya affected. Because it's a constant. Diba? So, therefore, it still will approach 1. Or that's still equal to 1. Okay? So, over, eto dito, ganun pa rin. So, this will approach negative 2. Ayan, na-define na. Plus, constant to siya. It will not be affected kung asan yung approach yung x. So, that would still be 3. So, eto na siya. This is now the shortcut version. Parang nag-substitute. Pero if we go much deeper in detail, eto na siya. Okay. Yun lang. So, let's now proceed to left-hand and right-hand limits. Or one-sided and two-sided limits. So, dito muna tayo. A function f of x has limit L at x equals a if and only if it has both left and right limits there, and these one-sided limits are both equal to L. Okay, so in symbol, the limit of f of x as x approaches a is equal to L. So, ito yung kaninang description and definition of limit informally. That is if and only if meron siyang right-hand limit. This is left-hand limit. So, a approaches from the left and that is equal to its limit when a approaches from the right. Okay? So, therefore, meron lang siyang limit kung both left and right hand ay may limit and they are the same, L. Okay? To illustrate this, yung gamitin natin is yung inansera natin kanina. For example, eto. Uy, nawala. Okay, look at this. So, di ba, x approaches to negative 2. So, you have this, di ba? Okay. We know that the answer for this is negative 3. Nansara natin kanina. So, negative 3 siya because as x approaches or if x approaches from the right, so meaning that is approaches from the right, so that would be negative 2 plus. Okay. Negative 2 positive. So, meaning from the right, the limit or yung value niya is papalapit sa negative 3. Ganon din kung mag-approach siya from the left. Ayan. Mag-approach siya from the left as it goes closer or creeps in to 8 to negative 2 pala. The value of the function also goes closer to negative 3. So, ulitin natin. So, ito yun. So, from the right and from the left, so, meron siyang limit. So, pag ganito yung itsura niya, both meron siyang left and right, then the limit exists. Okay. Okay. For problem 3.2, let us try to evaluate this. What is the limit of signum x as x approaches 0? Actually, nag-define na tayo in the previous discussion. Define na natin to. So, what would be the limit as x approaches 0? Okay? Actually, familiar tayo sa graph nito. So, ang gagawin natin, let us look at the left and right hand limits. So, evaluate natin muna yung limit of signum x as x approaches 0 from the left. Unahin natin yung from the left. Okay? So, when x approaches 0 from the left, that means we are, those values are negative, di ba? So, kung real number line pa, ito siya. If you have a real number line, this is 0. So, kung ang x is from the left, these are negative numbers. So, numbers that are close from the left, close to 0, pero nasa left ng 0, these are negative number. And we know that the signum of a negative number is negative 1. So, the result is negative 1, right? Right? For example, what value of x that is close to 0 but nasa left ng 0? So, let's say ito dito. Sabihin natin negative 0.01. So, negative 0.01, the signum of this is just negative 1. Okay? Now, if we take a look at the limit of signum x as x approaches 0 from the right, so 0 from the right, what would happen? That means, yung value ng x natin is close to 0 pero nasa right. And we know na pag nasa right, these are positive numbers. So, the signum of a positive number is always positive 1. We already defined this kanina, positive 1. Now, if you notice, the limit of the signum of x as x approaches 0 from the left is not equal to the limit of, this signum of signum x as x approaches 0 from the right. They are not equal. So, therefore, the limit of signum x as x approaches 0 does not exist. So, DNE. So, does not exist. Yan. Because it will only exist if they are the same, left and right. Dito magkaiba. Sa left is negative 1, sa right is positive 1. So, if we revisit the the graph of signum function. Okay, so here's the graph of a signum function. Wala siyang limit. It's ano, putol siya dito, no? When x approaches 0, putol, wala. There's no limit. Now let us try to evaluate the limit of sine alpha over alpha as alpha approaches 0. So what would this be equal to? So we'll do this by first, let's draw a triangle. Okay, so we have this right triangle. Let's call this triangle A, B, C. Ganyan na lang. So this angle here is alpha. Ito yung alpha natin. So what I will do is, ang B, I will swing this pa ganyan. Diba? So meaning B, i-trace ko din siya dito. So parang ganun ba? Parang naging radius siya. So si B, I will swing this here. Ayan. So eto na siya. Ganyan na siya. And I'll call this point na lang D. And if this is B, this is also B. So lagay ko na lang dito. Let us note that AB is just the same as AD na length. Okay? Then gagawin natin, let us extend this one, this point, I mean, project natin siya pababa. Ayan. So in this figure, lagyan natin ng label yung baba. Let's call that E. So in this figure, we notice that meron tayong etong triangle, which is the biggest triangle, triangle ABC. Then we have a sector ABD, and we have a smaller right triangle, which is AED. Ayan. And from here, we know that the area of the triangle ABC is greater than the area of the triangle, greater than the area of the sector. Area of the sector ABD, which is greater than the area of the smaller triangle AED. Diba? So pwede natin isulat like that. Or pwede din natin i-flip. Sige, pwede din ganito. The area of the smaller triangle AED is less than the area of the sector ABD, that is less than the area of the triangle ABC. Pwedeng ganon. Kanya na lang. So let's start with AED. Etong AED. How do we take the area of AED? So we know that area of a triangle is equal to 1/2 base times height. In this case, for this triangle, this is our base, AE, and this is our height, DE. Sige, sulat muna natin. So, that's 1/2 the length of AE. How about ganito? Sige, AE times ED, or DE. Pero di naman, DE na lang. Ganon. Then that is less than the area of the sector. So how do we compute the area of a sector? That is just 1/2. Sige. And i-recall ulit natin. Let us try to derive the area of a sector. So yung sector is parang slice of a pizza. Ayan. Okay. So eto siya. This is the arc length of the sector. And eto, this is the whole circumference of the circle. Okay, so if we are computing the area of the circle, ang whole, the central angle here is 360 or 2 pi, diba? So that would be area of the circle is to 2 pi. That is proportional to the area of the sector over this angle, the central angle, which is just alpha. Okay, so therefore the area of the sector is equal to, eto, transpose lang natin dito, that would be area of the circle over 2 pi times alpha. the area of the sector is equal to area of the circle is pi r squared over 2 pi times alpha. So from here we could cancel out pi. So area of the sector is just equal to 1/2 r squared alpha, where alpha is in radians, because eto sa ration proportion natin we use 2 pi which is in radians, so this should follow na in radians. Okay, so therefore we have 1/2 r squared alpha. Then ang r dito, ang r natin dito is actually this AB, di ba? Ang r natin is AB, so I'll change this r to AB. I'll square that times alpha. Now, that is less than the area of this triangle. This is just 1/2 times AE. Sorry, the bigger triangle na pala tayo. ABC na pala. That would be 1/2 times AB times CB or BC. Yan. So, let me just, adjust natin to. So, from here, we could just cancel out 1/2. May mga 1/2, mga 1/2 naman dito. We'll just cancel out 1/2. So, let's start with AE. Okay. AE. Ano ba yung, what is the value of AE relative to this, AD? Remember that this, how about kung ang AB, gawin na lang natin R para mas madali pala. So, let's just call this R, radius, and of course, AD, that's also R. So, meaning, I'll change this to R na lang. Sorry. R squared na to. Then, AB is also R. Is also R, which is AE, wala. Ayan. Okay. So, eto muna, tingnan natin to. What is AE equal to relative sa R dito? So, if we consider this triangle, yung AE is adjacent to alpha. And R is the hypotenuse of this triangle. So, therefore, adjacent and hypotenuse, that is cosine. So, we say that cosine alpha is equal to adjacent, which is AE, over hypotenuse R. So, transpose this to the other side. Therefore, AE is R cosine alpha. So, this is 1/2 AE, which is R cosine alpha, times DE. Ano ba yung DE natin? DE. DE is opposite, and this is hypotenuse. Again, we are considering this triangle, ang smaller triangle pa. So, opposite and hypotenuse, that's sine. So, therefore, we say that sine alpha is opposite, which is DE, over hypotenuse R. So, again, transpose this to the other side. We have DE is equal to R sine theta. So, this is R sine theta. And that is less than, we're supposed to cancel this out, no? So, eto, cancel out na lang to. So, wala na to. Okay. And let me move this here. Ayan. So, this is equal to R squared alpha. That is less than 1/2 R times, how about BC? Eto, BC, considering eto, this is for the larger, this is for the larger triangle, this one. So, if this is R, and this, which is adjacent to alpha, and CB is opposite of alpha, considering this triangle, so that is opposite and adjacent, the function is tangent. So, we have tangent, dito na lang, lampas na, tangent alpha is equal to opposite over adjacent. So, again, transposing this to the other side, you have CB is equal, or CB or BC, that's the same, R tangent alpha. Okay. Oh no, sorry. Wala nang 1/2. Wala nang 1/2 dito. Less than. Ayan. Wala nang 1/2. We already canceled out 1/2. So this becomes r squared sine alpha cosine alpha. That is less than r squared alpha. That is less than r squared tangent alpha. And again, we could cancel out. Common yung r squared. So tanggalin na lang din natin. So that means sine alpha cosine alpha is less than alpha and less than tangent alpha. So anong pwedeng gawin natin dito? Sunod, how about if we divide all terms by sine alpha? So kung i-divide natin, that would become this divided by sine alpha, that would be cosine alpha. That's less than alpha divided by sine alpha. That's less than, how about tangent? We know that tangent is sine over cosine. So if we divide that by sine alpha, cancel out to. So what will remain is 1 over cosine. So that is less than 1 over cosine alpha, or that is secant, diba? So ang gawin natin, let us flip this. Get the reciprocals of this, so that would become 1 over cosine alpha. That would be greater than sine alpha over alpha and greater than cosine alpha. So what I did is I just took the reciprocals of each term. Reciprocal of this is this, reciprocal nito is ito. Bakit mabaliktad yung sign? The inequality symbol is because this. So for example, if you have 1 which is less than 2, if you take the reciprocal of that, so the reciprocal of 1 is still 1, and the reciprocal of 2 is 1/2, and we know that 1 is greater than 1/2. So if you take the reciprocal, yung mas greater the number will become lesser this time. Diba? So, babaliktad yung inequality sign. Ayun. So, notice this. Ito. 1 over cosine alpha is greater than 1 over sine alpha over alpha is greater than cosine alpha. Now, what happens if we let alpha approach 0? We know that cosine of 0 is 1, diba? So, as alpha approaches 0, cosine alpha approaches 1, diba? And this also approaches 1. So, therefore, as alpha approaches 0, this approaches 1, and this also approaches 1. So, what number would be less than 1 but greater than 1? So, that is also 1. Diba? Naipit siya, na-squeeze siya. So, this is actually under the squeeze theorem. Okay, so squeeze theorem ni siya. Okay, so therefore we say, this is one of the theorem na kailangan memorize din ninyo. Madali lang naman. Therefore, we conclude that the limit of sine alpha over alpha as alpha approaches 0 is equal to 1. So memorize this one.